Hey everyone, this is our last video for Unit 1. So this is 1.9, interpreting graphs of functions. So when we are looking at the end behavior of a function on the graph, it's helpful to identify the key features of the graph. We should recognize where it's positive or negative, increasing or decreasing, and its end behavior. We should also recognize its extrema. For our discussion, we will refer to the graph below. A function is positive where the graph lies above the axis. So I'm going to highlight where it's positive in purple. So it's all about just being above the x-axis. I'm sorry, there my highlight and off the graph. So it's just about where it's above the x-axis. And negative, let me change colors. Where the graph goes below the x-axis. So just like I highlighted in purple, I'm going to trace over in pink to show you where it's negative. It is increasing where the graph goes up. So if we look at this, where is it increasing? Well, it's increasing here and here. And moving from left to right, and decreasing where it goes down. So where we're going down is here and here. And then at the very end, oops, when you want right there, decreasing here. Its end behavior describes the function at the arrowheads. That is the leftmost or the rightmost. So here we're going to label the parts that I just kind of went over. So I want you to pause and try to do this on your own and then come back. Okay, so you can see that these two arrows are pointing at where it's decreasing, and over here it's also decreasing. The rest of the graph is increasing. Where it is above the x-axis is positive, and below the x-axis is negative. Some points on the graph of a function can be described as a relative maxima, the plural is maxima, or a relative minima, plural minima. A maximum, or an extrema, which can be a maximum or a minimum, is where no other nearby points have a greater function. Oops. I flip-flopped it. I'm sorry. Let's go back. A maximum is where no other points nearby have a greater function value. A minimum is where no other points nearby points have a lesser function, and these points are called extrema. The function is considered to be neither increasing nor decreasing at the extrema. So if we look at our example, these 2 points here are maximums, or maxima, and these points down here are minima, because it's the smallest values, the relative maxima, relative minima. So now we're going to do lots of describing. Describe the features of the function below. All right, so the domain. So domain is what possible x values could we have? And in this case, we can have all real numbers. So that means from negative infinity to infinity. If we explore our graph and look at our range is only ever positive. So that means we start at 0, and it's closed because 0 is included, and we go to infinity. Our positive interval is when it's above 0. So in that case, it's all real numbers because it's the x values that we use to describe the positive, and the entire graph is positive. Negative is the empty set. There are none. Increasing. So where's the graph increasing? Well, it's increasing when x is greater than 3. So that means we can write that as x is greater than 3, or we could say 3 comma infinity, because that's going to continue forever. It's decreasing when x is less than negative 5. It's hard to say. Negative 5. Or I can say from negative infinity to negative 5, comma. And again, we don't include that extrema in that point. It's also decreasing, and when x is more than 2, but less than 3. So let's write that as an inequality, saying 2 is less than x is less than 3. So we'd say and 2 comma 3, parenthesis. And those are both in parentheses. It's constant between negative 5 is less than x is less than 2. Or we could say parenthesis negative 5 comma 2. It has a relative maxima. And it doesn't really have a relative maximum. It has a relative minimum, so there is none. It has a relative minimum at 3, 0. And behavior left as x decreases, y increases, and right as x increases, y increases. And that's how we would completely describe the graph. And so for additional practice, you're going to try some of these on your own. If you have any questions, please let me know in class.